Hello everyone, today we will discuss semi-parametric pH model. Semi-parametric pH model, and it is nothing but the Cox pH model. See, first of all we have to understand this meaning of the semi-parametric. See, here are the two parts of this semi-parametric. One is parametric, another one is non-parametric. If you have ever seen my previous video in the playlist of survival analysis where I briefly discuss about parametric and non-parametric, I suggest you to go and look at them. And here I just simply explain you in short what is parametric and non-parametric. Basically, a parametric is kind of a thing where the parameters are fixed. And what I mean by fixed parameters, I mean by fixed parameters that its probability distribution, the distribution that will created by this fixed parameters will be specific. You can say that now we will have fixed distributions. For example, Weibull distribution, exponential distribution, and it has a parameter like lambda where it is fixed. And what these fixed parameters do, the fixed parameters, like for example, suppose this is a exponential distribution. These fixed parameters make this exponential distribution fixed, or we can now identify what kind of or what sort of a distribution is this, because it has fixed parameters. What if we got something like this kind of a shape? We cannot form any distribution here because this distribution doesn't follow any specific distribution. Because of why? Because it does not have any fixed parameters. So there is the case when we discuss about this non-parametric world, where there is no fixed parameters, and this parametric and non-parametrics creates a semi-parametric pH model. Here we just specifically discuss will be Cox pH model. Suppose h of t given x is equal to h naught of t e to the power x prime beta. And if you want to expand this one, h naught t exp of beta 1 x1 plus beta 2 x2 up to beta p xp. So here we have p variates, so we go up to p. And here there is an important fact that we have to notice. There is a two parts actually. If you notice these two parts here, this part is basically non-parametric, and this part will be parametric. As we already mentioned that parametric, there is a fixed parameters. Now what is the fixed parameters? These betas, beta 1, beta 2 up to beta p, they are the fixed parameters in this case. And what is not fixed parameters? Because if you look at this h naught t is a baseline hazard, and this baseline hazard has no fixed parameters. Here the t is does not follow any specifically. When t will create a distribution, it will be totally unknown. Yes, it has a distribution, but the distribution will be unknown. So here two pairs, non-parametric and parametric, and these two pairs creates this thing, and this is semi-parametric metric. So that is why Cox pH is also known as semi-parametric pH model, because it has a non-parametric part and it has a parametric part. And there's a question coming to say why we need to study semi-parametric pH model in the context of modeling the survival data. Because of why? Because we are introducing covariates. And what is this covariates are? These ones are the covariates: exponent, x prime, beta. It's the part introducing throughout the covariates. So whenever we go for modeling with the covariates, see, in real life data, it is often required that you have to introduce the covariates. In the real life data, you doesn't have always the baseline hazard only. So covariates introduced in real world data. So it is very much important. You have to introduce covariates, and whenever you just introduce covariates, creating a model is some kind of a difficulties you will find. That is why Cox proposed this model, and he introduced this model, and he just gives us this semi-parametric model where one is non-parametric, one is parametric, and that is the how you just find a specific distribution. Then you will just create, you just calculate this estimates of these betas, and just you can inference over the distribution. So that is the reason why we use semi-parametric pH model. Thank you very much.